Hello everyone, welcome to tonight's Science and Nature. My name is Casey and I'll be your host tonight. So just a few housekeeping items. As always, we are recording this presentation live on Facebook and we'll be uploading it afterwards to people online. If you have any questions, just let us know in the chat, and everyone in person, thanks again so much for coming. You can help yourselves with some refreshments in the back of the room, and we'll be taking questions at the end of the presentation. So I'd like to a moment to respectfully acknowledge that we are on the traditional territory of the Haudenosaunee. We offer our gratitude to the Mohawks of Akwesasne for their care for and teachings about our earth and our relations. We are grateful for the time and knowledge that our neighbors share with us, and we strive to improve the health of the Great River. So if you want to know what's happening around the river and the River Institute, then follow us on LinkedIn, Instagram, and Facebook. And to see this presentation and any previous ones, you can check out our YouTube channel, or there's the Science and Nature website at the bottom of the screen. So here's just a few events happening around the Upper St. Lawrence area. So Riverkeeper is having a speaker series as well happening, and the next one is on Wednesday at the River House in Ottawa, and it will be the Swimmable City. If you're looking to get out to do something fun with the family, then check out the Tilt Treks as it's happening throughout the summer. On August 29th, there is a Glengarry Honey and Pollinator Festival happening at Alexandria Island Park. And also the Cornwall Library officially launched their Library Summer Reading Club last Saturday, so be sure to register as they have many fun programs happening every day, including the River Institute hosting a few throughout the summer. So all these events and more can be found on our River Strategy website, and if you have an event coming up, just let me know and I can add it as well. So our next Science and Nature will start back up again in the fall, as we're going to take a summer break because everyone's schedule gets really busy in the summertime. So stay tuned, and we'll be posting about the new S&N presentations in August. So tonight's presentations, presenters. So first is Erin Smith. So Erin is a postdoctoral researcher at the River Institute, where she primarily works on the Great River Rapport project. She earned her PhD in Applied Bioscience from Ontario Tech University in 2022, and her bachelor's from McMaster University in 2018. Erin's research interests include water quality, lower aquatic food web dynamics, and community-engaged research approaches. And then Emily Dereshi. So Emily's role at the River Institute includes coordinating the St. Lawrence River Strategy and leading a community engagement initiatives. In addition, she's a course instructor for the Environmental Tech program at the St. Lawrence College in Cornwall. Emily has a Bachelor's of Arts in Environmental Studies with a minor in Biology from Carleton University, a Bachelor of Education from Ottawa U, and a Master's of Education in Environmental and Sustainability Education from Lakehead University. And then I will also be presenting tonight. So I took the veterinary assistant program and worked in vet clinics for 5 years, then took the environmental tech program in Cornwall. I'm involved in various different projects at the River Institute, but mainly on the research and tech team and community science. My main goal or passion is communicating and breaking technical language to the community so that we can all understand and learn together. Right, so without further ado, I'd like to bring our first, I guess, Erin up first.
Thank you. All right, thank you so much for the intro, Casey. Okay. Yeah, so today our presentation is entitled Temperature Rangers to the Rescue, Filling Water Temperature Gaps in the St. Lawrence River. So our theme is going to be around water temperature, a little bit about climate change, and also how we're using community-based science to fill in these data gaps for water temperature. So first we'll start off by just setting some context, talking about the Great River Rapport project, which this is housed within. Then we'll talk about some of the methods that we're using to monitor for water temperature. We'll give you some of the findings from our water temperature indicator and our loggers monitoring project. And then we're going to get into some of the volunteer monitoring programs. So Em's going to explain how those work, what they are, and at the end you get a fun little bonus, which is a demo with using some of our Water Rangers kits. So I want to start off by thanking our team. So this is a group, project. We have a lot of people involved, including researchers, visual communications, our project leader, Lee McGaughy. So this presentation wouldn't be possible without all of them and their contributions. So I want to start off by thanking them. Also want to thank our partners and collaborators. As you'll see, hopefully throughout this presentation, it's a highly collaborative project, and it really wouldn't be possible without our different partners, contributing, working with us. And so, these are a handful of most of our partners, but there's many more also. And also specifically the Mohawk Council of Akwesasne and their environment program, who this project was co-founded with. So a little bit of context for you about the Great River Report. Maybe you've heard of it before, maybe not. But it's a project that came out of questions from the community. So if you're from the area, you might be aware that there's the area of concern, which is answering questions about different issues in the river. But we wanted to go broader. We wanted to look at the entire upper St. Lawrence River from Kingston, Ontario to Valleyfield, Quebec, and see what are the broad trends, what's going on long-term spatially happening in the river. And so that's this Great River Report project. And so it got its name. Everything in this project, it was intentional, from the name all the way through to all the research that we're doing and how we're communicating that research as well. So the name Great River comes from the Mohawk name for the St. Lawrence River, the Gana de la Wanena. And also the rapport part, comes from the way that we're working, right? We're working with our partners, working with community members. And so this dialogue, that's two ways, right? I know today we're presenting to you, but we also want to hear from you, right? We want to hear what you're thinking about, what your concerns are, what your priorities are. So it's meant to be this two-way or multi-way kind of conversation within the project. And so what does that look like? What does that actually mean? So we call it's a holistic approach to an ecosystem health report. So maybe you've heard of ecosystem health reports before, where they give a letter grade, like the water quality is an A+, right? And that's useful because it does give us some information about what's going on. But we wanted to do this a little bit differently. We wanted to have this holistic approach where we're answering different questions, not just, what is the quality related to a certain threshold or on a scale, but what are the stressors that are causing the issue? What are the long-term impacts? What are the other things we should be concerned about in the future? So we're kind of taking this holistic approach to the science we do, but also bringing in these other priorities and perspectives to the project. So we bring in Indigenous perspectives. So the Wahanda Galawadakwa is a key part of that, of framing the project, thinking about all elements of creation, their roles and responsibilities, and how do we honor that through the research we're doing. Bringing in community, right? So when we do our indicator reports, we talk to community once throughout the process, but also especially when we're done, to make sure is what we're finding reflecting what you're seeing. Are there things that you're seeing that we're missing that we need to look into further, right? So it's that collaborative approach to doing this research. So how do we work? We have this kind of 10 steps that we tend to follow as we work through the river rapport. And about the first 4 basically are setting the scene for the river rapport. And then the last 6 are ones that are continuously and kind of iteratively worked on as we go through our indicators. So starting by defining the boundaries of the region. So as I mentioned, we go from Kingston, Ontario to Valleyfield, Quebec. So that's sometimes called the international section of the St. Lawrence River, or the upper St. Lawrence River is how we tend to refer to it. So that entire stretch along there is where we look, and on both sides of the border, not just the north side or the south side, but both, so that we can holistically see what's going on across the borders. We asked the community. So that was the first step with this. Because the community came with us to initiate this project, we came back to them and said, okay, well, what are your concerns? What are the things that we should be focusing on that maybe other programs are missing? So we started with that, with a community survey, and took that, and then we brought that to the scientists, and they brought together those concerns and said, okay, here's some indicators we can look at. Here's data we can use to analyze these things that people want to know about. From that, we were able to select our indicators, and I'll show you just on the next slide what those indicators are. And then the last steps, as I mentioned, are ones that we work through as we go through each indicator. So identifying, gathering data, which I'll talk about how we do that. Conducting a scientific investigation, doing all the stats and the reading and bringing together the information. We collaborate. This is something that happens throughout the entire process. Then we translate the science and spread the knowledge. That's part of what we're doing here today. And engage in ongoing conversations. And then we hope to help people to take action. Again, something else we're doing today with the Water Rangers kits. So here's the list of indicators. So if you've been at some previous Science and Nature talks, we've talked about some of the other ones, including nutrients and the American eel. Today we're going to be focusing on water temperature, but just kind of looking broadly at this list, hopefully you can get the sense that we're trying to cover a broad range of different indicators that cover different components of the health of the St. Lawrence River. So as I mentioned, today we're going to be talking about water temperature. So you can kind of get into that mindset of thinking about water temperature. And we're going to start off by thinking about, why is it important to monitor water temperature? Why is it something that we should care about? And here are just 4 components of it, but there's many more, right? Water temperature is a key part of determining an aquatic habitat for everything that's living in it. But specific issues or things that can come up when you have really high water temperatures, for example, are things like algae blooms, right? So if you ever see, sometimes there's surface blooms are the ones that we tend to see, right? Surface scum on, that can be an algal bloom, and that can potentially be dangerous sometimes, but also just a nuisance, right? If you have a boat and it's getting clogged up, right, that can be problematic. If you think about things like fish health, right, certain fish are sensitive to high temperatures. Temperature can change the oxygen concentration in the water, and that can be very problematic for fish health. Aquatic plants is similar to algal blooms, right, where you have those higher temperature, it can spur more growth. And again, that can be a bit of a nuisance if you're trying to enjoy the water, if you're trying to go swimming. You know, a lot of people don't like the aquatic plants when they're growing out of control from things like high water temperature. And then finally, climate change, which I mentioned at the start, is going to be something that kind of will connect throughout as we're talking about water temperature, right? We know climate change is happening. It depends on where you are, what the impacts are going to be, but we know some of the things that are going to be happening in our region. And one of those is going to be increased air and therefore water temperature. So this is an estimate of looking at, we both have historic data, trends from the data, and then we also have some future predictions based on climate change scenarios. And so from this, we can see that there is an expected continued increase in water temperature. So this is air temperature, but it would be related to water temperature. So there's been a previous increase, and there's an expected increase in the near future as well. So this is something that we need to be concerned about and we need to be thinking about in regards to the health of the St. Lawrence River. And so this data comes from GLISA, an organization out of the University of Michigan. They shared this with us. So I'm going to hand it over to Casey to talk a little bit about community-based science and how it's helping to fill some data gaps for the water temperature indicator.
Thanks, Erin. All right, so what is community science? So community-based science is a community volunteer program that we have at the River Institute. It's so important to get the community involved and care about the river. So we use this community science to fill in the data gaps throughout the year, and then are able to use that data, translate it, and give it back to the community. So one of the components is our volunteer water monitoring program. So we have 4 programs currently. So this includes our freshwater explorers. This tests for basic water quality parameters such as dissolved oxygen, conductivity, chem strips, and water temperature. So that's what these backpacks are in the photo. Road salt stoppers. So this was launched last fall to help monitor what happens in our waterways when road salt enters it. Bacteria busters. This program is currently being launched, and this kit allows volunteers to test for E. coli. And then last but not least, our temperature rangers. So this program uses mini kits and focuses specifically on water temperature, which is also used as a climate change indicator as well. So how are we collecting water temperature data? So as mentioned, one way is through community science, but we also have an ongoing project at the River Institute since 2022. This project is deploying temperature loggers in the St. Lawrence River to help monitor near shore temperature. These loggers record the temperature every 15 minutes, and we have 32 loggers currently in the water from Chateauguay to Gananoque, and some sites have 4 years of data logged. So what are temperature loggers? So that's what this little guy here is. Erin, if you wanted to pass it around, thank you. So we attach that little small logger to rocks and deploy them at wadeable depths, ensuring random people can't find them. The balance of that is also making sure we can find them in 12 months so that we can download the data and then redeploy them. So we take a bunch of photos of the area and then draw essentially a treasure map to help guide us back to the logger location, then cross our fingers that the rocks have not been moved. So here are 2 examples of the maps that we've drew in the past. This one here is at Sutherland Creek, and then the one on the right is across from Polly's Gut. And just to let everyone know, these are not there anymore, so they won't be there. So here's a map of where the temperature logger, of where we have the temperature logger data. So right now there are 32 loggers in the water. So last year we moved more than half of the loggers to FINS sites. And for people who are not familiar about our FINS program, FINS stands for Fish Identification Near Shore Survey, where we use seine nets to help to capture near shore fish, measure and ID them, then release them back into the water. We also do water quality measurements and eDNA, but now with the loggers, we have year-round data of water temperature at these sites now. And as you can see, it's from Gananoque and then all the way to Chateauguay at the top. So now I will pass it to Erin.
I'm back. I know you guys clapped me off, but can't get rid of me that easy. Okay, so yeah, I'm going to talk a little bit about the data collection process for the River Report project, with giving some examples with the water temperature indicator. So yeah, with the River Report project, we're really trying to gather as much data as we possibly can. So we're looking at all possible sources. So that includes academic monitoring programs, government monitoring programs, and more recently, we've been putting a big focus on getting community-based science data. So when we're searching for data, we're looking at databases across these different sectors and just trying to get as much as we can, whether it's open access, sending requests to authors to use their data and thereby bring them into the project as well. So by doing this, we're able to get a lot of different data that can help us to span a large temporal and spatial range so that we can really get a good picture of what's going on. Because sometimes you might have an isolated study which gives you a certain finding, but if we bring all this data together, we find we can get more robust understanding of what's going on across this large river. So for the water temperature indicator, you can see move it out of the way. You can see the different data sources that we have. So we have kind of different code names depending on, who they're from or what project they're from. But basically the idea here is that you can see we have a lot of different sources that we're using, and they are that mix of, as I said, government, academic, River Institute projects, and then some community-based science with the water rangers, and even the loggers that Casey's been telling you about. And again, that helps us span across the river, right? If we only had, say, one color of these dots, we might only have 1 or maybe 2 sections. And so by, again, having these different sources, it helps us to better understand the full river.
Okay, so now I'll go over quality assurance. So how do we know that the information from volunteers are accurate? What do we do with this giant data set? So this is from our community science data. So once we have the data collected from community members, we refine it so that we can use it for analysis. So we work closely with water rangers, and they have an amazing open data platform that anyone can access. On our end, they also have a great quality assurance tool that will flag any information entered that seems the slightest bit abnormal. So some common mistakes in the past was entering water temperature data into the air temperature or vice versa. This tool is great because it saves us a lot of time looking through every single observation, which means that we can then take the data faster and analyze it faster. So when an observation gets flagged, it shows on my end so I can look at it more closely. Some of these were really easy to identify where the mistakes were. And then also to eliminate guessing, we also asked members to take pictures and record their findings and the results. So it makes it easier for us to know what the value actually was. And so it eliminates the guessing game. When I figure out what the actual correction is or the actual value, I can either edit it or accept it on their end. So once we have legitimized the flagged observations, we can now download the data set and then use it for scientific purposes. So now Erin is going to talk about what we found from that data set.
Okay. All right, so talked about all these different sources. We're bringing together the data. And so now with the indicator, again, we're looking at all that data together and trying to understand what are the trends that are going on. So first, just want to talk about where the data is coming from a little bit more with regards to the community-based science data and see what's been happening with our monitoring program specifically for water temperature. And so this is showing our observations over time for water temperature through the Water Rangers program. And the different colors represent the different sections of the river. So you can get an idea of the spatial spread of where these observations are coming from. And so you can kind of see over time, generally, we have an increase from our first 3 years. We still had a decent amount, but not as many observations. 2020, of course, we all know what happened that year. There was looks like one person that decided to go out and take a sample for us, but otherwise, of course, it was a quiet year. But then since then, right, especially in 2022, we see a really big spike in observations, right? People wanted to go back out and really start to collect that data, which is amazing. We had over 100 observations that year and spread across a lot of the different sections as well, which is really nice, again, to help with that spatial coverage. A bit of a drop in 2023, but then in 2024, we really started this community-based science program. And we were able to expand it a lot more. And so the last few years, we've had pretty good observations. And of course, with 2026, right, we're just about halfway through the year. And so we expect that we should be around where we were the last few years, maybe just under 100 observations. So that kind of shows that when we're putting that effort in, sharing the program, right, we are getting responses. People are monitoring and giving us that data. And then, of course, we can give it back to them as well. So looking at the broader trends of water temperature in the river. So this is bringing together all of these different data sources I talked about before, right? Government, academic, community-based science, and looking at the seasonal trends. And so this is for the main channel of the river. So there's, differences in main channel tends to be lower than the near shore. But overall, we tend to see increases in each season. So especially for winter, we saw the largest increases in water temperature, which is really interesting because there can sometimes be a gap in winter monitoring. So it's good to see that we did have data and we were able to show this trend. And this has been shown in other water bodies as well, where there's a lot of warming happening in the winter. Spring, we still saw an increase, and same with summer, but just to a lesser extent. And then fall, you can see there's something a little funny happening there. And what we think is that it's potentially just due to these kind of skewed data in the 1970s. We have 3 years there, so it could potentially be those were just very warm falls that year. So we're still kind of trying to figure out exactly what that is. But we know that overall, right, if you look at the data basically from 1990 on, right, there is an increase for the rest of that data. So it seems like it's just those 3 points. There's something different going on there. We also looked at day of year trends to see what the seasonal patterns are with water temperature. And as expected, right, we had our highest temperatures in the summer and especially the late summer. But again, this kind of just highlights that gap that we can have in the winter, right, where we only have a few different observations. So it shows the importance of having these programs like community-based science where we can have people out monitoring year-round, where some government monitoring or academic monitoring might not be out there in the winter season. And then spatially as well, we actually had a pretty strong trend along the river where we had a lot higher temperatures in a few sections. So in the Thousand Islands region, in Lake St. Lawrence and Lake St. Francis. And so this tends to be these more fluvial sections of the river. So they're, like Lake St. Lawrence and Lake St. Francis, they're more lake-like, right, in their properties. And so that seems to be likely what's causing these increases, where there's more of these embayments where the water's sitting, warming up, shallower areas where we just get this warmer temperatures occurring. So kind of interesting to see that along the whole river, we do have this trend across these different sections. Pass it back to Casey.
Thank you. So here's the temperature logger findings. So this is just an example of 3 sites with 4 years of data. We do have, again, like 70 some data graphs that we could show, but here's just 3 examples. So for location wise, Grays Creek is in the purple line, so the darker one, which is in between OPG, which is the green or the blue line, and then the Sutherland Creek in the yellow. So throughout the data in general, we visually saw a pattern of higher max temps over the years. So the next steps are to analyze the data to see if there is in fact a significant trend. The temperature logger The temperature loggers are important not only because they log for 12 months, but they're also filling in the winter gaps as well that Aaron had mentioned is very important. So an example on how we use this data was being able to find out fish spawning timing specifically to the St. Lawrence River, as fish have a specific water temperature range that they spawn during. This project is only one source of information for the water temperature indicator. So Aaron will go over a few other programs that we have used.
And so I've mentioned this kind of before. These are the three large groups kind of sources of data that we're getting. So government programs, academic, and community-based science. And so just to kind of give it a fuller understanding of, there's benefits of each approach. They're all a little bit different generally in the way that they do monitoring. So things like we looked at things like longevity, consistency, seasonality, and spatial coverage to try to evaluate, what are the benefits, what are the things that we get out of each of these different programs. So for example, with longevity, we see that government monitoring generally tends to have a lot of that long-term data. That's where we got that 1970s data, right? Without that, we only could go back, I think we had maybe the early 90s was the earliest otherwise, right? So we're able to get more of that long-term data, understand more of these trends like with climate change, where it takes a long time, right, where we start to see those trends. So it can be really beneficial for that. Academic monitoring tends to be shorter. Again, these are generalizations, right? There's different projects that would, kind of go against this, but in general, they tend to be short term. And then community-based science, I gave kind of 2 stars as that right now it's something that's still building, but it has the potential to really be a long-term data source where if we keep these programs going, if we continue to have, support for these programs, they can help to contribute to that longevity in the monitoring, especially in nearshore zones where our community members are going out to take those samples. Consistency, kind of similar, right? Again, with the government monitoring, it tends to be pretty consistent of whether it's a certain station that logs every week or every month, right? They're pretty consistent with how those are being taken. Academic monitoring, again, it depends, right? There might be really consistent for a short period of time, but less so over a longer period. And community-based science, again, depends on the program, right? Some are really good where there's consistent monitoring at certain points. And so there needs to be that program in place to make sure that it is consistent. And I think Em might talk a little bit about, that's one of the things that we're doing with our project. Seasonality as well, as has been mentioned a few times here, right? There are some gaps, especially in the, get to the late fall and winter. So sometimes government monitoring programs do cover throughout, but not always. Same goes with academic monitoring, but with community-based science, right? We have a program that runs all the way through the winter. And so there's consistent monitoring through it. And then spatial coverage, finally, government monitoring, again, tends to have, 1 or 2 sites maybe on the river that they collect this data from, but less of that spread. Academic monitoring can be more spread out generally, again, depending on the scope of that study. But community-based science, right, as you saw, we were covering across these different river sections, so we can really get that large spread and access places where we can't otherwise, right? People can be accessing from their waterfront properties and getting that data there where we otherwise wouldn't get to. So overall, we presented a bunch of different things, but kind of the key messages here, right? We see an overall increasing trend in water temperature in the St. Lawrence River, and this seems to be primarily driven by climate change. There are higher temperatures in nearshore and sheltered areas. We saw some of those more fluvial sections tend to have those higher temperatures, like the Thousand Islands, Lake St. Lawrence, and Lake St. Francis. It's important to have data from different monitoring programs. So hopefully we kind of emphasize that point of looking at the loggers, the community-based science, right? All of those are contributing and helping to give us this overall trend of what's happening in the river. We need community-based science to help fill gaps for this indicator. So it needs to help with that longevity of continuing into the future to see, as we saw projected climate change, how will that impact the river? And especially again, in those nearshore areas where we're using the river, right? Where we're swimming and all the ways we use the river. And then finally, we just need to continue with the regular monitoring to identify climate change impacts into the future to really understand, again, the health of the river and what's being impacted. So with that, I'm going to hand it over to Emily, who's going to tell us all about community science in action.
Awesome. Okay, so I'm going to talk about our various community science volunteer monitoring programs that we have at the Institute currently. And as I go through these, I want you to think about how maybe you can get involved in this work and help us collect this very vital data. So first off, in our first program that we have launched is our Freshwater Explorers program. So this program was named specifically after the Water Rangers Freshwater Explorer Kit that you can see here, community scientist Ryan, whose mom is in the audience here today, is holding. So I'm going to show you the contents of this kit. It's like a little show and tell moment. Okay, so here's our Freshwater Explorers kit here. Very cute. I think it's an old, it's like thank you so much. Okay, some of the contents of this one. So this is general water chemistry parameters. So think of conductivity. There's also, that's nice, thank you. We also have water temperature on here as well. But it's also important to note the air temperature is an important piece to these kits as well. And very cool, both of these are included in here, and this one can be used for water and for air. Cue the ooh and the ah once again. Also in this kit, we do have test strips with these parameters that you've probably seen whenever you test a hot tub or a pool. We also have the Secchi disc, and we also have dissolved oxygen. So this is a more general kit. And so we can get a whole bunch of different readings that we can use in various indicators that we have with the Great River Report. But we found that people had questions about more specific things that are happening when it comes to water chemistry. Before I get to those ones though, there's our Temperature Rangers program. And of course, today's presentation has largely been about water temperature. And so we love this program because from the size of this kit, as you can see here, okay, they're relatively inexpensive compared to this one. And so it's mostly just focused on temperature. It also has test strips, but we're more easily able to spread them out and get community scientists out there testing the water temperature. The biggest thing we find with this program is that because it's such a small kit, people don't see that it has a big impact. And so it's about convincing folks that it is in fact important, which, as we know, this is an indicator of climate change. And so this is vital data. So next up, we have the road salt stoppers, action-oriented name here. And so this is where we're responding to those community concerns. People had questions about the impacts of road salts on our waterways. And we don't have all those answers. And so what are we going to do? We're going to get people out there helping us test the water to get those answers. So we have the Water Rangers road salt test kits. And so we got people out actually for the first time last season, so starting in the fall. So I believe we had 7 different sites being tested. This is including, you can see Mark here, who's a community scientist who's taking a sample on Brookdale and here in Cornwall. And so for each of these programs, we went about different ways of launching them. And so to start this one, because we had very few kits for this one to start with, we did a community input session. So we gathered folks at the Cooper Marsh Visitor Center and we asked them, where are you concerned about road salt? And then they had the opportunity if they wanted to also be volunteers in that program, which some of them did. We then didn't have to really promote this program too much. We did one post and we had basically our whole roster fill up, which was incredible. So we had people out testing, even some are continuing into today. And we also had blitz events. So we expect chloride levels. So chloride's what we're kind of looking for when we're testing for road salts, that and higher conductivity levels. We expect these to be higher after big melt events, big ice storms, because that's whenever the road salt trucks go out, right? And so we were kind of keeping an eye on the weather and we'd say, oops, storm. Casey would send out an email and say, road salt stoppers, it's time to do your work. And so it was another way to kind of get that impact of like, what were those peaks happening and how high are those peaks when they do happen? Obviously, a challenge with this program as well is that this is happening mostly over the winter. And in the winter, there's ice. So that imposed some challenges with being able to access data for every single month that we had this program going. But it's good to see ice anyway, especially when we think about climate change. So we'll take it as a win. With that as well, it's important to note that we can also have people report ice on and ice off whenever they upload their data to the Water Rangers platform, which in itself is super valuable data. This is just a highlight of some chloride data from up in Brockville from this program. So as you can see, we already have trends coming from our volunteer community scientists. And so we're really excited that we have this starting. This is available right on the Water Rangers website. You can go check it out yourself right now if you wanted to. And you can see where it goes a little bit higher in those winter months, just like we kind of expect. And then this is also showing, and this is hot off the press for our Road Salt Stoppers program. Ren Gravel put this together for us, actually. Thank you so much. This is just showing you the average levels of chloride from this program, from all our different sites that we had tested. Remember, only about 7. So this is just kind of an overall look at this program, not entirety of the watershed. We'd need more test kits for that. But all to say that if you see this orange line here, that's where it becomes toxic for organisms in the water, okay, at 120 milligrams per liter of chloride. And you can see that for the most part, the average is underneath that. So this is really good news for this area, but we're going to keep testing to keep an eye on this. And so that's the chronic exposure level, 120 milligrams per liter here in orange, and the acute is at 640. And so these are our chloride levels over time at different sites. And as you can see, we don't even go up to 350. So we didn't hit that acute level in this area at those sites. So that's promising news. And so we'll continue to grow on that. Next up, we have our Bacteria Busters program. And so this is another one of those programs that was hatched because folks had questions about, can they swim in the water? And we couldn't tell by looking at road salt stoppers, temperature rangers, or freshwater explorers. We could get an idea of the health of the ecosystem for things living in it, but can you swim in it and not encounter E. coli, for example, okay, at more toxic levels. And so our Bacteria Busters program was launched. So Water Rangers has an E. coli test kit. And so what's really awesome about this is that you don't need lab equipment to do this testing anymore. There's these little R cards, which is basically like a little agar plate. They're like cardboard that you can go put your sample on and incubate it in an egg incubator right in your kitchen. Perhaps you'll wipe the counter before you make dinner though. But this one, we had a site suggestion form. So we approached it differently to get the feedback on where we wanted to allocate these kits to. And so we asked people at different events and different partners who also interact with the community, where do they know that there might be concerning levels of E. coli that we should test? We also thought about, is there recreation happening here? Angling, swimming, paddleboarding, or do people care about it to try to allocate it so that it's more meaningful for the community? And so that's our form here. And we're also collecting road salt stoppers there too. And so this program, we did one post, you can see it here, and we've had overwhelming interest in it. It is so exciting. And so we've ordered more kits and we're hoping to get even more sites than originally planned. And so we will let you know maybe next year on how those results are looking up and down the river. And so in thinking about our volunteer monitoring programs, we have some lessons that we've learned along the way, and we've kind of tweaked it along the way as well to better serve the community and be more efficient and get really great data, of course. And so number one is the variety in promotions. We use social media, we use newsletters, and as you can see here on the screen, we go to community events, we try to reach youth as much as possible. And then we also, to engage youth, give a little bit of incentive. So of course, here in Ontario, we have students have to do 40 hours of volunteer service to graduate high school. And so students can actually get those hours through doing this volunteer monitoring with us. And so we've had some students take part because of that and then return after they've fulfilled their hours anyway because they liked it so much, which is so fun to see. We've also learned to do either a monthly or a bi-weekly testing schedule. It's more structured, you know what to expect, it's easy to stay on top of. And as Erin mentioned, you need to have that consistency to have meaningful data. So that's something we've been working on with our volunteers. And another lesson we learned is that people care. They care about the river and they care about what's happening with this water. So next steps for this program, we're trying to expand. So we went up to Brockville not long ago and did a workshop, and people were super interested in it. And so asked if we can come back. So we're doing 2.0 next week, which we're very excited about. So we're also going to be training our Bacteria Buster volunteers starting next week as well, and communicating results such as presentations like here tonight, right? I talked about the road salt results a little bit. We're going to be also sending out newsletters about those results and other programs as well. And then, of course, using that data and integrating it into those technical reports that Erin's been mentioning. And so achievements, we are using community science data and technical reports, which is such an exciting step in this work. It's a big talk in academia. Can this work be validated for scientific reports? And the answer is yes, as we've just seen, which is a huge feat. We can have more people out in the water helping gather information and fill important gaps. And we've had good engagement. As I said, people care. We also have repeat customers, as I like to say, repeat volunteers out helping us collect this data who are interested in learning and helping. And then, of course, with that, long-term data sets. The longer term and more consistent a data set is, the better it is. And we're seeing that already. And then at the end of the day, even if data doesn't get used, but it will, people are engaging with the water, and people will protect and care about what they know. So if you don't know about water, how can you protect it? So this is a really good way for people to get to know it so they can do so. And so kind of bringing it all together, we looked at water temperature analysis in more of a scientific way. We then talked about community science and how it's a promising way to collect this data. And then, of course, at the end of the day, this is all a really important climate change indicator. And so with this work, people in this room here today, and I know there's actually some community scientists in the room, have contributed data that's a really important climate change indicator. And so this data, maybe not today, maybe not tomorrow, but maybe 2 years from now, maybe a month from now, that data could be used to inform policy, or maybe even help us inform how to adapt to this changing climate that we have, and inform maybe some remediation efforts. So this data is important, and everyone has that ability to make that difference and help make change. So with that, we're going to pause for a few minutes to take questions, and then we're going to go into our mini Water Rangers demo. And so that is all. And if you're ready for questions, I will come around with the mic.
So when looking at the Water Rangers data, Casey, you mentioned that sometimes people accidentally maybe put the water temperature instead of air temperature. Are there any other common maybe mistakes that people are making that we should be aware of?
Yeah, so another common one, just come back. Another common one would be chloride and chlorine during our winter test kits was a huge one. And then also just like moving the decimal points, conductivity, instead of 300.1, it's like 30.01, and then that's a huge red flag. So yeah, just the little things like that.
According to your data on temperature, you say the trend is warming. Well, I've been observing the river for some time, and we in the past have had times when the river never froze at all, and now it's freezing more than ever, and the depths of the ice is even increasing.
Yeah, I mean, it's the thing with climate change, right, is that it's very variable, right? So every year is different. And so when we're looking at this, right, we aren't looking at ice data. So that is something that would be interesting to look into. I know there tends to be a lot of actually community-based science for ice on and ice off monitoring. A lot of places have historic where we go into the newspaper every year. So that is something that would be of interest to look into, definitely. And of course, you know, is related to water temperature. But yeah, when we're looking at this, you know, I had over 40,000 data points that I was looking at when I was looking at that water temperature indicator, right? So over this long period of time, and with all of this data put together, we do see an overall warming trend. And as I mentioned, actually the winter was the strongest warming trend. So ice is also, there's lots of other factors as well for determining ice forming, right? You know, things like wind, you know, even the seasons previous, right, will determine how strong the ice or when it's going to go on and off. So yeah, there's a lot of different factors, but it's definitely something that would be interesting to look into, the long-term trends for the ice in the region. Yeah.
Does more ice cause the river to be warmer because of an insulation factor?
In the winter, it can impact the stratification in the winter. But going into the spring, it would be usually later if there's like a stronger ice cover. So there would be a later kind of spring turnover when we have the stratification for the summer. So it would tend to be cooler kind of into the spring until that summer, those layers, the stratified layers of the different temperatures, the top and then the bottom. And then that kind of depends on what's going on in the spring and summer more so, but it would have more of an impact in the spring.
I just have something random to add to that. I have no idea if this is a real factor or not, but I'm also wondering if just like chemical composition in the water might affect like ice growth or not. Like I know that there's been a few factories that have shut down along the St. Lawrence River in the past couple decades, so I'm wondering if like you know, water pollution was contributing to ice preventing being formed, and now that those have shut down, more ice. I don't know. just
Yeah,
a random other factor I
potentially.
considered.
Yeah. I must say I'm not an expert on the like ice cover, but yeah, that definitely could be something, right? If there's especially like oils and that sort of thing in the water, I could definitely see that potentially having an impact.
Okay, so what we're going to do now is I'm going to very briefly show you how to use the Temperature Rangers kit. So by the end of this, you'll all be qualified Temperature Rangers. And you can go out and be like a Superman or something. So I'm going to first show you how to use it, and then I'm going to pass out some water samples for you to try it out. Okay, so we're just going to use the mini kit. As I have shown on the screen, it only includes two main things. We have our thermometer, which is for air and water, dual purpose, excellent. And we have some test strips, just a few in here, okay? And so the first thing you want to do whenever you take a water sample is to make sure that you get the air temperature. And so that's where you're going to use your little thermometer here. You want to go and hang this up somewhere in the shade so you don't get the heat from the sun absorbing into your little thermometer, about 1 meter off the ground, and hang it up. Could I get a tree over here, please? Casey will be my tree. Thank you so much. Very short tree. There we go. So she's going to sit there. You want it to sit out for about 5 minutes to settle. Okay. Next, depending if you have a cup, and so these kits don't come with the cup, but maybe you have one at home, or maybe you're near the shoreline, maybe you have a bucket, something like that. You'll take your sample. So whoop, that was the fastest sample I ever got. Here we have one here. So I am now going to take out a test strip. Now, the key thing whenever you take a test strip out is that we don't want to get the rest of them wet, okay? And unfortunately, we're always doing this near water, so it's not ideal, but we're going to do our best. So I'm going to open this up, okay? And as carefully as possible, and now my hands are moist because I touched the water, I'm going to get one strip out, and this is the hardest part of it all. There's one. Ta-da! We're going to close that up ASAP so that we do not get water in it. And we are going to dip the test strip in, okay? 2 seconds in, and then 10 seconds out, then you can look at the comparison. So we're going in, 1, 2, and now we wait. Pretty simple, right? And so this test is looking at chlorine as the first test, pH, alkalinity, and hardness, okay? And so chlorine is different than chloride. Chlorine is not naturally occurring. Now, we can expect maybe a little bit in some tap water and city water, but if we see any in a natural water body, that's a bit of a cause for concern. pH, potential of hydrogen, acids and bases. Most water bodies that we see around the St. Lawrence are going to be closer to that neutral, probably around an 8. But if you're looking at a bog, you would expect it to be more acidic, maybe like a 5, a 6, something like that. Could get lower, depending if you're in a real good bog. But all to say that these levels and what normal is different for every water body and different locations. So out in the channel of the St. Lawrence is going to likely be different than an inlet, okay? Just inshore, all right? We also have alkalinity. So that's basically how resistant the water is going to be to changes in pH. And then hardness. If you have a well like I do, you're familiar with hardness because of the calcification in your shower and for your hair quality, okay? And we would expect softer water in the St. Lawrence, okay? So probably about 100, 150 typically. And so this is where we're now ready. I think I talked for way longer than 10 seconds. We would then start looking at our little comparator here. The key thing here is to have consistent lighting. So to be honest, the lighting in here is not ideal. And if you have sunglasses on, take those off. And to always start at the lowest value. We're always tempted to jump ahead to the one that looks the closest, but always work your way up because you might be surprised, okay? And so I'm not going to try to tell you, I think it's orange number 1 or 2. I'm going to let you all try it in a second so that you can see it up close. The next thing, now we have our tree here. Tree, how we doing? Thank you so much. We now need to get our water temperature. So all we have to do for this one, for a Temperature Ranger kit, is dip it in, and we're going to wait about a minute just to let it settle in and get its temperature reading. With all of this, data is not useful unless it is shared. And so in these little kits, we have a little notepad. Now, it is not enough to just write your results on the notepad. You also need to upload them to the Water Rangers Open Data platform. But this is an excellent place to start. They also have an app on Water Rangers, but if you're like me, when you're out in nature, it's not fun to be on your phone, so it's more fun to put it on paper anyway sometimes. But just remember to upload it to the platform so that we can use that information for our technical reports. So with that, I am going to hand out some water samples, and in small groups, I'm going to give you a thermometer and some test strips, and you are going to try testing that water sample. And it is tap water, so it won't be too exciting. So here I come with some Timmy's cups in good Canadian fashion. You can be a group. And there you go. Maybe a group of 3 over here. There we go. Here's your water glass. Okay, sounds good. You can be a group. There you go. Timmy's cup. Okay.
All right, so while everyone in person will be testing water, I'm going to wrap up the online version.
I'll hand that
so if
to
you
you.
do want to come out and test some water, just reach myself or Emily for the water monitoring program. But for now, stay tuned for our next Science Nature will be in September. So we'll be posting it around August. So thank you.